11s, welcome back for some more content. Today we're looking at exercise 4E on determining rules on page 160 of your textbook. Now, exercise 4E is actually pretty much stuff you guys already know, just with added application of stuff we've covered over the last couple of weeks. But the actual core content or core concepts of this exercise is stuff that you guys have already done. Now remember, before we actually determine the rule of anything, and it's the same as the function family stuff we did last time, we have to find out how many constants there are to be defined. So for example, if it says y equals to a squared plus b, then obviously a and b are the constants being defined. So we need to find out how many constants there are to define, and then the second part of that is just determine how many bits of information, right? So obviously if there are two constants we need to find, then we need to find 2 bits of information. That's pretty much it. Let's get right into it. So the first example I have here is a rectangular hyperbola, and we can tell that because there's no square at the bottom of fraction. The rectangular hyperbola y equals to a over x plus 8 passes through the point -2, 6. Find the value of a. Now it's pretty obvious, this one here, that there's one bit of information that we need. That bit of information being the a. And we don't actually define the y and x. I know this confusion sets in a bit because y and x are variables. We're keeping them as variables. We can substitute whatever value of x and we get whatever value of y, or vice versa as well. But the idea is a is specifically a certain number. A has to be a very particular number or numbers in order for the point for the rectangular hyperbola to pass through the point -2 and 6. It has to go through a very particular point, and so that value of a has to be a very particular value. Whereas y and x are variables, we keep them as variables. So the one bit information we're looking for is a. Obviously, the one bit information is a, which means we use the one bit information, -2, 6. Pretty straightforward. This is exactly what you guys already know. We sub in the point, so sub -2, 6, and I get -6 because remember, oops, not -6, +6, because remember that's x and that's y. So 6 equals to a over -2 plus 8. I'm going to go ahead and take away 8 on both sides, which gives me -2 equals to a over -2. I then multiply both sides by -2 to give me +4 equals to a. Now, in this situation, they specifically ask you to find the value of a. If it doesn't say that and it says to find the formula, you then have to go ahead and substitute it back in and get y equals to 4 over x plus a. There's not much else to it. That's pretty much it. So find out how many constants you have and then determine your bits of information. The second example I have here is one that's heavily related to circles from our last lesson. So we're going to go ahead and find the equation of the circle whose center is at the point 1, -1 and passes through the point 4, 3. Now, if I was to write out the general form, I've got x minus, I think it's, yeah, h, sorry, squared plus bracket y minus k squared equals to r squared. Now, theoretically, there are 3 bits of information here that we need to put in. There is the h value, right? We've got the h value, and we've also got the k value, but we've also got the r value. Okay. Ultimately, we're going to focus on what bits of information we have. We have the x value, we have the y value. Now, in most situations, a point doesn't give you 2 bits of information. In this situation, it does. Because we're looking at the center, it's given to us as the center. We know the x value, we know the y value. Awesome, that's our 2 bits of information, plus we know this third bit of information. So let's go ahead and put this into practice. So we've got the center at 1, -1. Hopefully, remember that when we put the value of the center, the x value, for example, we always put the negative of what it says, because we're adjusting for that change. So, if my center is 1, -1, I know that my equation becomes x minus 1, because it's positive here, squared plus y plus 1 squared equals to r squared. And there we go. Now we only have the one constant left, and we still have 4, 3 to use as a bit of information. I'm going to go ahead and substitute that in. Remember that x equals to 4 and y equals to 3. So we end up with 4 minus 1 squared, let's write that a bit better, plus bracket 3 plus 1 squared equals to r squared. From there, I'm going to go ahead and expand that, or simplify that rather. So I end up with 3 squared, which is 9, plus 4 squared, which is 16, equals to r squared, which gives me 25. Now, I'm going to go ahead and write r equals to 5. That's just for my own sake. But we can actually substitute that back into our original equation in order to find the equation of the circle, which is what the question asks us to do. So I end up with bracket x minus 1 squared, let's rewrite that bracket there we go, plus y plus 1 squared equals to 25, and voila, that's in the general form. There are other ways to do this, but in my opinion, this is the easiest way to approach this question. Finally, this is ripped from the exercise question 14a. All it's doing is giving it to us in graphical form, and I just want to make sure you guys are able to appreciate's the wrong word, acknowledge the different parts or bits of information provided in an example like this. So we know the general equation, pretty straightforward. Now the question asks us to find the rule for the graph. The exact same process. The only thing is it's given in graphical form. So we know the center, and it's a really good idea to write this out in a test situation so you don't forget. I find it's easier to interpret a graph and then interpret it algebraically rather than skip from the graph into our solving. Okay, so we've got the center at 2, -2, and we've put a point at -5, -2. Now, I'm going to do this exactly the same way as before, and then I'll show you a slightly different way, purely just out of observation. So, from here, I'm going to go ahead and write in my center. I know that the value has to be x, remember the negative, so x minus 2 squared plus y, and that becomes obviously a positive 2, so plus 2 squared, which equals to r squared. Now I'm going to go ahead and substitute my values of -5 and -2 in order to find value of r. So I end up with -5 minus 2 squared plus -2 and then plus 2 squared, which gives me r squared. Simplifying that, I know I get -5 minus 2, which is -7. Squaring that gives me 49 plus -2 plus 2, which gives me 0. Squaring that gives me 0, so I get rid of the plus, and I write equals to r squared. And therefore, r equals to 7. I'm going to go ahead and actually rewrite the equation, so I end up with a final answer of x minus 2 squared plus y plus 2 squared equals to equals to 49. Now, the easier way to doing this is purely out of observation. Now, it doesn't apply in most situations, but in this situation, I can see that this has the same y value. They're aligned. Just purely based off that, I can actually try and figure out what the radius is without having to substitute the value. If I look at this, I know that it goes from here to here, a value of 5. I know that because it goes -5, which is my x value. I also know that x value here is +2, which means that this distance from there to there is going to be +2. Adding them together gives me 7. If I get that, therefore, I know that my radius is 7. And once I get up to this point here, I can just substitute r equals 7. So I can just go straight from here. I'm going to write x minus 2 squared plus y plus 2 squared equals to 7 squared, or you can rewrite that as 49 if you'd like. So that's it. That's all there is to exercise 14e. Please let me know if you have any questions. If I went through this too quickly, please send me an email. I'm more than happy to improve upon feedback. Best of luck. Let me know if you have any questions.